Welcome to the DNS Reconnaissance module. In this module, we will attempt to gather network information using DNS. DNS is an abbreviation for domain name system. I've heard domain name server, domain name service, and its main function is to translate FQDNs, or fully qualified domain names, into IP addresses. If you're unfamiliar with DNS or need a refresher, you can read up about it using Google. If we were to drop by Google and look for DNS, perhaps Wikipedia would be a good start. Then we would find many references to DNS. Let's click on the first link. Indeed. So we have actually a nice document here describing the history of DNS and basically the inner workings. If you do need a refresher, this is a good start. So basically DNS, or a DNS server, holds records for FQDNs. These records include A records, or host records, MX records, NS records, and PTR records. An A record is a record for a computer on the internet or a host. An MX record is a record for a mail server. An NS record is a record for a DNS server. And a PTR record, also known as a reverse lookup record, a pointer record, actually translates from an IP to an FQDN. There are some other types of records, but they are out of the scope of this module. Before we actually start gathering information, we need to get acquainted with a couple of tools. The first tool is the host command, and the second tool is the nslookup command. Let's start with nslookup. nslookup is basically a DNS client. Let's just type up nslookup. What we've actually done now is connected to the closest DNS server to us, which is usually defined in our TCP IP settings, and we can actually query the DNS server. For this example, our target will be checkpoint.com. Now obviously we have absolutely no malicious intention for this domain, we're just gathering information using DNS. So if we type up the FQDN www.checkpoint.com, we get an answer, exactly as we'd expect from a DNS server. We asked for the IP address of this FQDN, and this is the answer we got. Now, at minimum, a DNS server needs to hold two types of records. The first record is an MX record, which is a mail server record, or the IP address of the mail server which serves the domain. The second type of record is an NS record, which is the address of the DNS server serving that domain. If we now wanted to see which mail servers serve the domain checkpoint.com, then we would type the following: set type MX, and now we would query the domain checkpoint.com. Now what we actually see here is that checkpoint.com has 3 mail servers. And there's actually something quite interesting here. If you look at these numbers here, which indicate the mail preference or the cost of emails reaching these servers. Now this cost is actually something virtual. It just means that mail will prefer to go to lower cost servers first. So all mail will actually be relayed to this mail server first. If this server is down for some reason, it will go here and here respectively. Okay, now let's try to look for DNS servers belonging to checkpoint.com. So we will now type set type equals NS, and again issue the domain we're looking for, and we actually see that we get 2 name servers that are authoritative for checkpoint, NS1 and NS4. So this information can be basically gathered for any domain. These are usually mandatory records which every DNS server needs to hold. So how would we actually go about gathering information from DNS? Well, probably the first and most obvious way would be to try to guess valid DNS names. Let's take a look at this example. If I try to resolve the name www.checkpoint.com, then you see that I actually get a positive result. The host command gives me the output. The address for checkpoint.com is so and so. Now, if I were to try this for a non-existent host, then you can actually see that the result is different. I get the output host not found. So if we were to try to script this, say by using a file with predefined names, I've prepared such a file here. Let's take a look at it. So I've got a file with common DNS names, and if I were to try to brute force each and every name to see if it exists or not, I could actually find a few hosts. So let's write a short bash script that will do this for us. Now, we will be encouraging you to actually write short scripts in bash as the course goes along. So let's start our script. Let's call it do DNS A, and we will start this script with a bash shebang, and let's start with a loop for name in do host So what this script basically does is iterates through all the lines in dnsnames.txt and takes the value that it received, appends checkpoint.com to it, and issues the host command. Let's see how this script runs. Wow, so that's a lot of output. If we actually look at this output, we'll see that several names were found and several were not. This was not found, and this one has address. So if we were to filter out all the lines with has address, then we'll get a much cleaner output. So let's just do that quickly. And we'll grep has address, and we'll try running that again. There, that's much cleaner and much nicer. Now, what I'd actually like to do is do a bit of text manipulation on this result to get a cleaner, nicer list. So let's just output the result into a text file. Let's call it cp1.txt. And if we cut the output into delimiters and we use space as the delimiter, so we see we have one space here, another one here, and another one here. So we would be looking for the fourth field, then we will actually just get the IP addresses. Now if I wanted to be thorough, I would sort this and make it unique, thus eliminating any duplicate IP addresses. So let's shove this into a file as well, cpips.txt. Basically what we have now is a short list of IP addresses belonging to checkpoint.com. What we can do now is actually continue to the second type of information gathering technique, which is very similar to the first one, but rather than brute forcing possible FQDNs, we will be trying to brute force reverse lookups on IP ranges which we know belong to the organization. Now let me just show you what a reverse lookup looks like. I'll try to reverse resolve this IP into a FQDN. So I'll just issue the command host and the IP, and we can actually see that this IP has been resolved to dariel.checkpoint.com. So again, let's try to script this. Let's write a new script, do DNS -r this time. And we'll start with our shebang. And again, we'll start with our loop for IP in sequence. And we will issue the... Actually, let's make this script a bit better. Let's make this script accept an argument. So network equals, we'll take the first argument. And now we will just do a host on the network argument and on the number. So basically what this script does is takes an argument from the user and appends the numbers 1 to 254 in sequence to that string and issues the host command. Let's see if this works. Okay, let's try running that. And input the network range of the first network that we found. That was 194.29.32. Wow. Okay, so that is a lot of information. Let's just input this into a file. And now what we're going to have are the checkpoint host names, FQDNs, and IP addresses for that range. So let's do a bit more of text manipulation on this file to extract the names that we need. So let's clear the screen. And this time we will again want to cut with a delimiter of space and find the fifth field name. And now basically what we've got is a list of checkpoint FQDNs. Now again, let's filter out some of the useless stuff. So let's just ask to see all the lines that contain checkpoint.com. And there we have it. And again, we can sort this and unique this and enter it into a file. Final.txt. So basically what we have here is a long list of checkpoint FQDNs in a very convenient arrangement where we can actually use this text file and incorporate it in other scripts. We've come to the end of our first part. Final.txt. So what we end up with is a long text file. We can actually find out exactly how long it is, with 238 different FQDNs for checkpoint.com on that specific network range. We've come to the end of the first part of the DNS reconnaissance modules, and in the next module we will talk about other very nifty things that can be done with DNS, such as zone transfers. And other neat and surprising things.